Hey everybody, this is Garrett with Earth and Time, and today I'm coming to you from a very unique place. About an hour north of Houston, I'm at a place called the Blue Lagoon. What's fascinating about this is an old quarry that filled up with spring water, which gives it this blue appearance. And with that, there's some unique geology in this area I want to share with you as well. So come join me today. Let's check out the Blue Lagoon. Let's get to it. First of all, just looking at the scenery is absolutely stunning. I will say it's a first come, first serve here, and it was $30 entry fee to come into the park. And so far I can tell you it was well worth the $30 because there's not very many places, especially in southeastern Texas, where you're going to get actual cliff exposures, right? And although these ones are from quarries or from a quarry that was from the late 1800s, early 1900s, it still creates this amazing picturesque scenery and view that we normally don't get here. Now, the rocks we see from this vantage point or this viewpoint are actually made up of what is known as the Catahoula Formation. So this would have been deposited after the time of dinosaurs, well before kind of the big glacial ice ages everybody's familiar with, and back when the coast of Texas was closer to us than it is to the present day coast. And in that environment, you had these large rivers coming down and dumping into a much older Gulf of Mexico. And that's what we have captured here within the Catahoula Formation, are these old rivers that used to dump into that area. All right, so I moved up from on top of that cliff where we weren't able to get the best view of the rocks down into this parking area. So when I came in and I paid to come into this Blue Lagoon, they assigned me to what was known as the gorilla parking area, or the gorilla overhang here. And I gotta tell you, it is absolutely stunning. You can see this beautiful aqua blue water behind me, and there's some really cool outcrops. So let's go take a look at those. I'm working my way along a trail heading towards the cliff where we did the intro at. And what I want to point out again is just how stunning this water is. Now, why does the water look like this? Well, the spring water that comes in here is coming through some pretty clean sandstone, which means there's not a lot of mud and dirt. And so when the water comes out, it can stay this pristine, beautiful blue color. I always get asked, how about wildlife when I go places? So I have seen some turtles. I don't think there's fish here unless somebody brought them in, and so they've been introduced. Now you can see there's a number of weeds down here, so you do get a little bit of, I guess, if you will, lake weed that's going on in this area. And the site is a popular diving location, which we can see the buoys out there, and there's actually a series of dives folks do here, including, I think they have a sunken boat here, maybe it's the SS Minnow, you know, a callback to Gilligan's Island. And actually I just saw some divers preparing just down the road from me. However, we're here to talk about the rocks, so let's talk about the rocks. So here's a look at the Catahoula Formation. This would be late Oligocene, so somewhere maybe around 25 million years ago, this was deposited. And at that time, the Gulf of Mexico coastline was farther north than it is today, somewhere between where I'm at now and the city of Houston. And what we can see in here is we have a very sandy bed. In fact, it's pretty coarsely sand. And we can also see there's some cross beds associated with this. And so this gives me the indication that this is probably some kind of fluvial deposit or some kind of deposit related to rivers. The other interesting thing here is there is petrified wood, and I actually think this may be a piece of bone from some Oligocene animal potentially cruising through the area. And it looks like there's a couple pieces here that may be bone, and then there's some petrified wood as well. And here's a beautiful piece of petrified wood within the fluvial matrix. So these trees were dying or being washed away by these rivers coming through here in the Oligocene to late Miocene. And they're being carried downriver, eventually deposited, and then preserved so we can find them today. I've worked my way around a little farther, and one thing I want to point out is you can really see the cliff face over there. And so I was standing on for the intro at the top of that cliff face, and this is a really nice exposure of the Catahoula Formation. And we can see how there's beds or breaks in it, and those are different fluvial deposits from different times that may have scoured into one another. And so as geoscientists, we'll come out here and we can map those out and actually start putting together a story. What's interesting from a story point of view is I work my way over to this outcrop. I can actually see chunks of petrified wood in here. But what also is interesting is there seems to be some kind of weakness in this plane right here between these rocks on the left-hand side and these rocks on the right-hand side. And I'm going to go ahead and say I think there's a fault that's running through here. In fact, we can see how as I come down here, this has all been jumbled and beaten up and it's starting to erode. So I think there's a fault running right through this section where we have more competent rock on the left-hand side, more competent rock on the right-hand side, and right in the middle we can see there's erosion going on. And you see actually trees are taking advantage of this fault zone as well because it, water will percolate down in there so they can grab it. Pretty cool. And they're totally not my fault. And if I look down, there are little fish in here, by the way. So there are some fish in here. One of the things that's really interesting here, and I'm not sure how to show it to you all yet, but apparently opal occurs within the catahoula formation and is one of the cements that actually holds this rock together. Now, I don't know if we're going to be able to see examples of that here, but I want to take a look and see if I can find some opalized sandstone. I think that'd be really cool. As we look along this outcrop along the lake, one thing I want to point out as I zoom in here is there's a rust color associated with these rocks. So what that tells me is that there's been some later water that's gone through these rocks and deposited iron. So we see that brownish reddish color, and sometimes they'll create these what we call bands. So they'll call it Lisagang bands, and they're associated with iron rich waters running through these sandstones. So fascinating, the material in here are leaves, and I can see a leaf here, I can see part of a leaf here, as well as wood. And we can see the wood here, we can see a piece of wood here, and it's all been, or a lot of it's been replaced or augmented by the iron that went through the system later. This is an absolutely beautiful rock and a great example of a type of rock that gives us an idea about what kind of life was around, at least tree life, plant life was around some of these river systems back 25 million years ago. For those of you who saw my video looking at the dinosaur tracks in Utah in the Iron Springs Formation, this looks very similar to Iron Springs Formation, which has been pretty well documented, including by me, talking about what the paleogeography of that looked like during the time of the dinosaurs. We actually could see dinosaur trackways in there. Now, what's interesting to me, if we saw dinosaur trackways in that kind of environment, and this looks very similar to what I saw there, I wonder if there's been any mammalian tracks found associated with, or bird tracks or other types of tracks associated with what we're seeing here within the Catahoula Formation. Something to think about. It would be the right environment deposition, or EOD, to do that. So I've worked my way down a couple hundred yards or so, and I found this beautiful outcrop I wanted to share with you all, where you can actually see the bedding. You can see a lot of fossils in here as well, and I'll get you a little closer. I'm still looking for this opalized section of sandstone, and I'm trying to test that by using a black light, but it's such a bright, beautiful day here, which normally I wouldn't complain about, but it makes it very hard to use a black light against the rock to look for opal. One of the things to recognize as we look at this is we can actually see there's different what we call beds in here, or layers, and we can take a look at these layers and understand what's happened through time along this river. One thing that's happened is we can see some of these beds carry some tree material, so we can actually see a chunk of petrified wood in there. We can see some sections that are maybe a little bit more chaotic and very, very coarse. And then we can see some beds that are a little bit finer. They're still pretty coarse, but have a little bit more of a structure associated with them. And by seeing this, we can start putting together a story about how this river moved through time. So I'm holding my black light against the rock, and I can see a couple little areas where I see some fluorescence popping in there. It's really hard to make out because it's such a bright day, but there definitely are places where I can see some of that fluorescence, suggesting that maybe parts of this are indeed opalized. Now, It's not super obvious in this. It would be a very fine cement that'd be opalizing this. And really what we'd want to do is look at this underneath a microscope to truly understand what the cement looks like. And check out this bed of just all kinds of debris. It looks like plant debris. There may even be some potentially bones in here. I'm actually not sure what all I'm looking at, except to say there's a lot of, I think, bones and petrified wood within this rock. That is really cool. And look at the underside of this muddy channel, I guess. I am not sure what that feature is. Maybe it's part of a tree limb. There's definitely a leaf just to the left of that. But that is pretty cool. And this is the type of environment, if I'm looking underneath something like this, one of these muddier deposits, that I'd want to look for things like trackways or footprints, or where maybe some snails crawled through, or what we call ichnofossils or trace fossils. At this outcrop, what's the story I see? The story I see is this was a pretty active fluvial system. There's a lot of wood material in here, so it was obviously cutting through something maybe not too dissimilar from what's around me right now. Some kind of forest, some kind of lush vegetated place. Also, it looks like there's maybe some opal cement in some of this. I'm not 100%, but I did catch a little bit of fluorescence as I was using my black light. But again, it's a tough day to look for that. Let's keep walking down. Let's take a look at some more of this catahoula formation and see what was happening in this part of Texas 25 million years ago. And as I slowly work my way around the lake, the lagoon, it's nice coming back and taking a look. And I don't know if anybody can see, there are some little fishes out here swimming around, but they're very small. Now, from a history point of view, I was really interested in where the sandstone they were mining from here, this catahoula formation, where that sandstone was going, what it was used for. I'm guessing it was probably used for parts of Huntsville. And at some point I'll go down there and talk about the 7 hills of Huntsville. Much like Rome, Huntsville's founded, it has 7 hills, which one of the reasons it was founded there, because it had some areas of elevation. Potentially the quarry, rock and stone would end up going that direction, including building some of the early buildings there. So they did talk about Huntsville, Texas as the first capital of Texas at one point, and they actually have a place called Capitol Hill, which is where Sam Houston State University now resides. So I can envision some of this rock going that way, but maybe we'll learn more when we go there. This is a really interesting rock, and it's out of place, which is a shame, because what we're actually looking at is part of a fault zone. So you can see all these lines coming through. So this rock has been ground up from movement along a fault, but it's a boulder sitting out of place. I'm not sure where that fault is. Continuing along the lagoon here, I've actually come to a much finer type of deposit. So this may be what they're referring to more as a lacustrine or lake type deposits. It's a bit muddy and fine grained sand towards the top. As we go lower, it looks like it gets a little bit more coarse. In fact, we can see where a tree branch was caught in, and it was actually kind of deformed along one of these river deposits towards the bottom, and then it looks like it gets finer and finer and finer as we go up, suggesting there was a river in place, and eventually that river ended up slowing down and we end up with some kind of lake deposit. As I look at the lagoon and I look off to the left, an observation I just made is that these rocks don't look very stained. I move to the right, there's a lot of iron staining right through this region, and if you remember looking at that last block where we saw a lot of iron stains, suggested we were along a fault zone. And then if I look over on the other side and back the other direction, there's a little bit of iron staining, but it's not quite as pervasive. I wonder if I'm standing along one of these fault zones right here, because I can see that iron staining. I can't really see the offset we'd usually see in faults, but there's definitely fluid flow. So at least there's a fracture system here, which is most likely related to faulting, that we can trace through this area. Pretty cool and fun to recognize. There's this very fine grained material again that I ran across as an outcrop right along the edge of the lagoon. And this would be a good place to come look for things like leaf fossils potentially, if you can find a big enough chunk that hasn't been too beaten up through time. It's really becoming a bit of, actually it feels a lot like diatomite. And I actually wonder if this is diatomaceous, which for those of you who are interested, I made a video on diatomite and on Miocene lake deposits, which look a lot like this and feel a lot like this. And those deposits are actually what they're used for kitty litter. So I'm actually very curious if these are similar. And yay, I found evidence for a fault. So this smooth section right here is actually a fracture plane, and actually maybe even a fault plane, but we can see how it's polished relative to the stuff around it, and it's got a smooth side, although it undulates. But I can look at this and I see there's striae. There's grooves that have been carved because one side of the rock moved down relative to the other. That's neat to see. So this suggests there's a normal fault running through this area. So now as we're moving around, we've seen evidence of ancient river systems, these fluvial systems. We've now seen evidence of an ancient lake. I think all this fine-grained white stuff down below me here is all related to that. And so this may actually be diatomite or diatomaceous earth, which tells me there was an ancient lake here as well. So that is pretty cool to see along this walk, and starts telling me about this amazing environment 25 to 15 million years ago. And as a reminder, I did a whole episode on diatomite and these ancient lakes in the Basin Range outside of Reno, and they look just like that stuff we were just looking at. So check out that video. I'll link it up above, up here somewhere, and you can check that out another time and learn a little bit more about diatomaceous earth and the fact that that's actually what they used to use, and maybe still do in some instances, for cat litter. Pretty interesting. I've officially made it to the very end of the lake. So I'm parked way over there somewhere, and I worked my way along that side past all those little, I guess they're shelters, and worked my way over the cliff face over here, and now I've arrived over on this side, and we can actually see those diatomaceous sediments on top where they had that beware cliff. There's that, potential cat litter, if you will, and you can see how that's a stark difference and contrast from there over to the cliffs we see on the right hand side, which also may give me a hint that maybe there's a fault running right through that section as well. Potentially, I see very different rocks on this side of the lagoon compared to that side of the lagoon. And to get that, we could have a transition of environments, but we also could have some faults, and we have seen evidence of faulting here. So that's the more likely explanation for it. Working my way around the end of the lake, and I did find this tree growing out of one of these lake deposits here, which is pretty cool to see. Seems like a happy little tree. Channel by Bob Ross there, growing out of this probably nutrient-rich ancient lake soil. Now I'm straight across from one of the big cliffs I was at about halfway through my walk on the other side, and I wanted to show you all this outcrop, which is a series of beautiful cross-bedded stream deposits. So the reason we can see this texture we see is tells us the water was flowing in a certain direction. What's fascinating is the rocks are black. So here's the big question: why do we think the rocks are black here? Well, it could be a couple things. One, it could be some kind of manganese or some other staining associated with secondary materials, much like we get staining associated with the iron. Also could be, and I didn't bring my rock camera with me, but if I hit these, I may have smelled oil. So we are in a known oil and gas province, and so this could have been an ancient reservoir rock for oil in this area as well. I'm not sure what the right answer is. If somebody else knows, please let us know in the comments down below. What I can tell you is that these are some pretty phenomenal chunks of sandstone, and I'm going to guess if it was darker and I could actually use my black light, that these are some of the opalized sandstones that we've heard about in this area, because they have definitely a different texture, a different shine to them than the other sandstones we've seen around this area. So they're pretty distinct in their look. I also think the sand is so beautiful that I imagine this is what they were chasing after in the quarry, because the texture is gorgeous on it, and it's just this really nice fine grained, potentially opalized sand, which gives it this beautiful texture and color, and definitely could be a decorative rock used for somebody's countertops or used as building material. From the sandstone, if I look just underneath it, we can actually see some more of this diatomaceous lake deposit. At least I think that's what it is. And that tells me that maybe this nice clean sand that's here could be related to a shoreline along the lake. And maybe that's why it's so clean and beautiful. And we don't see the large cross beds, although we see some on the other side of it. Maybe this was a lake shoreline, or this could just be some really nice fluvial deposits. Pretty spectacular. And so you can see the difference in rocks. Here's one of these iron enriched sandstones. Here's one of these really fine grained mudstones, almost diatomaceous type soil. Here is this, I believe it is opalized sandstone. So you can kind of see the difference. In fact, this one may be opalized as well, but also have iron staining. So I found this little arroyo or washout, and what I want to point out is you can actually see some of the iron stained cross-bedded sandstones over there, and you can see all the stuff underneath it is much finer, right? So tell me we're in a muddy system, or maybe one of these lacustrine systems, again, old lake systems, and then we have some more resistive units on top, which could be some kind of fluvial system from what it looks like, and it's also stained with iron. So I'm wondering if this cut through here isn't related to some of the faults that we see. In fact, it actually lines up almost perfectly with one of the faults we saw if I go straight across that direction. So it's a view from exactly opposite of where we saw some of that faulted material over there at that outcrop. And there's actually not a lot of outcrops on this side. Although today, right now, at least there's some shade, which is nice. So definitely the north side of the lagoon has better rock outcrops so far than the southern side. There are a lot of boulders on this side, so you can at least take a look at the boulders and a lot of loose material like this that you can see. I think this is mostly plant material in this chunk. There are a number of boulders on the southern side of the lagoon, and one of the things that's interesting is, at least in this boulder, is there's a story here. One is that this is very coarse grained. I don't know where it originally came from, but what's fascinating about it is you'll see some of this finer, basically those lake deposits that we were seeing. Chunks of that were actually incorporated into this. So that tells me that the story I was thinking about on the other side, where I had some of this finer grained mudstone, maybe lake deposits, maybe some muddy overbank flow deposits from the river, were eventually getting cannibalized, or these fluvial systems or rivers are going over those. And indeed, that's what we see here, is that we're actually seeing chunks of this finer grain material getting incorporated into some of the fluvial stuff. So the fluvial was cutting down into it, basically cannibalizing it, and it was being carried along and eventually deposited with these streams. I've worked my way down to the other end of the lagoon, pretty close to where I did the intro, which was on top up there somewhere. But we can actually get a better view of this cliff face and just see how massive it is, and start making some observations about the geology. So starting from over here, we can actually see it has a different bedding profile, if you will. You can see there's slightly smaller beds on top. You can see the different resistive, non-resistive units. But as I pan to the right, we'll actually see that finer material actually wedging up and out until eventually disappears at what would it be over, excuse the tree, the top of this formation, and we actually get a much more massive sandstone, which looks like it has a lot of fine portions in it towards the bottom, which is what we observed on the other side as well. From this vantage point, let's talk about all the observations we made and what we learned today. We learned that this catahoula formation had a lot of different types of rocks associated with it, from very fine grained things like muds to maybe diatomites to coarse sandstone associated with ancient rivers and ancient lakes about 25 to 15 million years ago. We did see some evidence of faults and fracturing. In fact, we can see some of those straight across from us right now. We also, through the course of these observations, made observations we can make today. And that is, there are still lakes, there are still river systems, and they operate in a very similar pattern. And I'm going to zoom in real quick. I've got a little lizard there doing push-ups to show you. He was also very excited about what we learned today. It's a little green anole. And I think we learned that you can walk around something like this, make some observations, start putting together a story, which as a geoscientist is much like being a forensic scientist, or really is being a forensic scientist, like being in something like CSI. We also saw rocks that were probably cemented by opal, a pretty unique process and pretty exciting. Seeing those faults and that secondary fluids of the iron going through the faults was pretty neat as well. Not to mention the fact that we had this stunning backdrop the entire time. So with that being said, if you enjoyed this video, you all know what to do. Give it a thumbs up. Please leave comments down below. Do you know of places like this where you're from? Or have you been out here to Blue Lagoon or something like that before? What do you think about the geology here? Is there somewhere else here in Texas or Southeast Texas you'd like me to explore, or somewhere even beyond the Texas boundary that you'd like me to explore and learn about, and take you along with me to take a look at the observations and see if we can put together a geologic story as we walk around? If you haven't already, please subscribe to the channel. All your subscriptions mean a lot to me. I enjoy taking you all along with me to learn. And with that being said, see y'all.